Here we have a SAT math question. Okay, let's go to the information. If 2 to the x power equals to 3 to the y power equals to 6 to the negative z power, then what is the value of 1 over x positive 1 over y positive 1 over z? Okay, now let me consider the stuff what we have over here. That is 2 to the x power equals to 3 to the y power equals to 6 to the negative z power. Okay, here these three terms are equal. For example, if the value of this 2 to the x power is assumed as 5, what is the value of 3 to the y power? So the value of this one is also 5. The value of this one is also, 6 to the negative z power is also 5 because all of them are equal. So, but I do not know what is the exact value of 2 to the x power. Okay, just for example, I said 5. Okay, now let me assume the value of this 2 to the x power as k. Then the value of this 3 to the y power also must be k, and the value of this one also must be k. So let me assume all these three terms are equal to k. Since all of them are equal to k, we can equate each term separately to k. So first let me equate the first term, that is 2 to the x power to k. Then I'm getting 2 to the x power equals to k. Okay, now I'm going to get rid of this exponent x. So if I want to get rid of the exponent x over here, what should I do? I have to raise both sides to the power of 1 over x, which is a reciprocal of the exponent x over here. Okay, now let me raise both sides to the power of 1 over x. Then I'm getting 2 to the x power raised to the power of 1 over x equals to k to the power of 1 over x. Now we can consider the power of a power rule in exponent, that is a to the nth power raised to the power of n. Here the base is a, we have exponent m, and for the complete stuff we have n. Whenever we have two exponents like this, what we can do is we can multiply the two exponents using the power of a power rule in exponent. So that is the stuff what I've explained over here is called the power of a power rule in exponent. So the same thing we have over here. So that is we have base 2 and exponent x, and for the complete stuff we have the exponent 1 over x. Now what we can do is we can multiply the two exponents over here. Then I'm getting 2 to the power of x times 1 over x equals to k to the power of 1 over x. Here x will cancel out. I'm getting 2 to the first power. 2 to the first power is just 2 equals to k to the power of 1 over x. Okay, now let me equate the second term 3 to the y power to k. So then I'm getting 3 to the y power equals to k. Now to get rid of the exponent y over here, I raise both sides to the power of 1 over y, which is reciprocal of y. That is 3 to the y power raised to the power of 1 over y equals to k to the power of 1 over y. Let me write it. Okay, 3 to the power of, now what we can do is we can multiply the two exponents. Then I'm getting y times 1 over y equals to k to the power of 1 over y. So this y will cancel out. 3 to the first power is just 3 equals to k to the power of 1 over y. Okay, now let me equate the third term to k. Then I'm getting 6 to the power of negative z equals to k. The same thing. So to get rid of the exponent negative z, I have to raise both sides to the power of negative 1 over z. That's a reciprocal of this negative z. Then I'm getting 6 to the negative z power raised to the power of negative 1 over z equals to k to the power of negative 1 over z. Now what we can do is we can multiply the two exponents. Then I'm getting 6 times negative will become positive. Z times 1 over z equals to k to the power of negative 1 over z. Now z will cancel. 6 to the first power is just 6 equals to k to the power of negative 1 over z. Now let me consider this equation over here, that is 6 equals to k to the power of negative 1 over z. I write this 6 as 2 times 3 equals to k to the power of negative 1 over z. I have already solved for 2, that is 2 equals to k to the power of 1 over x, and also I have solved for 3, that is 3 equals to k to the power of 1 over y. Now I'm going to plug in this k to the power of 1 over x for the 2 over here, and this k to the power of 1 over y for the 3 over here. Then I'm getting k to the power of 1 over x times k to the power of 1 over y equals to k to the power of negative 1 over z. Here I multiply two terms with the same base. Whenever I multiply two terms with the same base, what I can do is I can take the base ones and add the exponents using the product rule of exponents. On the right side, I write this stuff as it is, that is k to the power of negative 1 over z. Here, two terms are equal with the same base. That is, we have base k on the left side, base k on the right side. Whenever two terms are equal with the same base, what we can do is we can equate the exponents. When I equate the exponents, I'm getting 1 over x positive 1 over y equals to negative 1 over z. Now let me add 1 over z to both sides. Let me do it. When I add 1 over z to both sides, it's negative 1 over z, positive 1 over z will cancel out. On the left side, I'm getting 1 over x, positive 1 over y, positive 1 over z equals to, on the right side, 0. Now I got the value of the expression 1 over x, positive 1 over y, positive 1 over z. Its value is 0. We find 0 in answer choice C. The correct answer choice for this question is C.